Okay, it's 1 o'clock Central Time. Welcome to this HDF clinic. We're back. Last week we canceled because there was an ECP event going on and we were afraid that nobody really would show up because everybody was at the other event. And so, but we are back in full force this week. And interestingly enough, somebody posted a question in the Google document and actually filed a ticket on GitHub, even better. And let's talk about that first, and then we'll do another round of questions, should there be any, and otherwise I have some prepared material. Okay, so the question that the user asked, and maybe I'll give a little bit of background first. In HDF5, as we all know, we can sort of construct all kinds of interesting data structures in memory, and then we can write these data structures into an HDF5 file and then also read them back. So far, so good. But what also is supported in HDF5 is there is a so-called data type conversion pipeline that says, well, for example, somebody gives me an HDF5 file and they recorded something as an integer data set, but my application, my machine learning application, for example, prefers floating point numbers. It would be rather tedious to first have to read those integers as integers and then do some kind of in-memory conversion. So one of the nice things when they work with HDF5 is that for compatible or convertible data types, that conversion can actually happen on the fly. And even further, you as a user have a degree of control over that conversion process, because in HDF5 sort of we distinguish between so-called hard conversions and soft conversions. The idea basically being some of these conversions are supported in processor by the compiler finally, and so we don't have to do anything special like the typical integer to floating point conversion and so forth. That's well taken care of by compilers. But then there are also so-called soft conversion or software-based conversions, where you as a developer, as a user, can supply a conversion routine, and then the HDF5 library, as you read that data or when you write the data, depending on which direction you are going, when the library encounters a read or write operation where you have to specify the destination type, and the destination type could be the in-memory or in the file type, depending again which direction you are going, the library will look for registered soft conversions, and if it finds your conversion routine, it will just apply that, and everything is fine. So that's sort of the model where we are coming from. And so the interesting observation someone made here was actually with another seemingly rather simple scenario where you have string data sets, and if you remember in HDF5 we have sort of two flavors of strings. Fundamentally, we have sort of fixed size or fixed length string types, and then variable length string types. And then these two types of strings, you can then change things like the encoding. So it could be ASCII, it could be variable byte encoding like UTF-8. And then if it's fixed size, you also have things like padding and padding, and then the background and things like that. So, and in the specific case here, we are dealing with a variable length string type, and they're just null terminated. And we are looking at two encodings, ASCII and UTF-8. And so for people who may not be as fluent in Unicode, Unicode is this set of code points that represents sort of characters in all kinds of languages. And there are different encodings for Unicode, and one is UTF-8, where you use, it's a so-called variable byte length encoding, where you use between 1 and 4 bytes to represent these code points. And then there is UTF-16, UTF-32, and so forth. But in the specific case of UTF-8, we know that ASCII is actually a strict subset of UTF-8. So every ASCII string is necessarily a UTF-8 string in terms of the encoding, but not the other way around. There are plenty of things that you can represent in UTF-8 that you just cannot represent in ASCII. And so one would think that if we created a data set with ASCII encoding in an HDF5 file, for example, and then later read that data set back, but our encoding in memory was UTF-8, we would think, well, that's like converting an integer to a floating point number. We are sort of widening, in a way, the range of values in that type. There are just many more code points, all Unicode code points that can be represented using UTF-8 rather than ASCII. And we would think that should be a slam dunk, because ASCII is a subset of Unicode, of UTF-8 specifically. And that should work. As it turns out, not so fast. It doesn't. And this is what the author of this question noticed. And he was actually so kind to report his experience. And there's actually an interesting twist to this that I come to in a moment. But he also provided a reproducer. So if you go to his GitHub ticket, which I think is on the same web page here, it's linked here. But if you go here, he provided a reproducer. And what's so interesting about this reproducer is also that it appears that the behavior is actually inconsistent. So the first thing that happens is when you try to read that ASCII encoded string data set, for example, in the file into a UTF-8 encoded character array, you get an H5d read error, and basically the essence of the error message is this, where HDF5, the data type conversion pipeline, is basically complaining and saying, hey, there is no conversion. I don't have a conversion from ASCII to UTF-8, which is again silly. But the plot thickens. It turns out that if the author tried all kinds of combinations. So he found that if you do the following, that you take a UTF-8 encoded, not an ASCII encoded, a UTF-8 encoded data set, and read that into a UTF-8 encoded character array in memory, that works just fine as expected, because the type is identical. There's no conversion necessary. But then if you repeat the experiment that previously failed, where you're reading an ASCII data set in a file into a UTF-8 encoded character array in memory, that succeeds. So it appears kind of strange that as a side effect of first, without any side effects, reading a UTF-8 encoded data set and then reading ASCII to UTF-8, that works. But if you do it the other way around, it fails right in the first instance. And in this GitHub ticket, so if you didn't follow that, in this GitHub ticket, I actually created my own little reproducer here. So the argument is basically, here is my own reproducer. So I have here something that is clearly UTF-8 encoded and not ASCII. So I stored that in the HDF5 file, and I'm reading it into memory as UTF-8. That works. And if I read after that, I put these ASCII characters into the data set and read that into a UTF-8 encoded data set in memory, if you wish, array. That works. But if I drop that argument, I basically interpret that as a Boolean flag to reverse the order in which I attempt these operations. You get this error. So, and here's the error that person was reporting, where it can't really find a conversion path, and that's that. So all I can say, good catch. It's, in my opinion, definitely a bug, because ASCII is a strict subset of UTF-8, and the conversion path is absolutely clear. In fact, byte by byte, the encoding, the bytes to encode an ASCII character in UTF-8 are exactly the same. So it's really an embedding of that character set into UTF-8, and that should just work. And so it's a bug, and we need to look into it. Interesting enough, it's been lingering there for a long time. So the person tried it with 110.7, 110.12. I tried it earlier with 1.8.22. The problem is there in 1.8.22. So it's been lingering. I mean, it's kind of an odd twist, but very good catch. And yeah, it's a bug. That's all I can say. Does that maybe is the person here?
Yes, thank you.
Hi, how are
you? Yes,
nice
to meet you. Thank you very much. Actually, it's not. I reported it, but we are a team from EPFL, Blue Brain, Pramod. You can talk if you want, but yeah, we have many use cases that we use HDF for our simulations, and in this particular case, all the use cases always read some other part of the file before accessing this part of the file, and then we never hit this bug. But then Fernando, I don't know if he's in the call, he actually accessed this ASCII string, right? And he was getting this error, and we thought that it was ourselves, that we thought that maybe we were not using HDF5 properly. But then we took even this example from the documentation, and we saw that actually it feels like something is wrong. That's why we wanted to bring it up in case we were using,
yeah, because I don't see, when you read UTF-8 to UTF-8, I don't see as a side effect of that some type of data type conversion routine being installed, because I tested that. If you look at my example, I commented it out. But here there is actually a way where you can, there's a function called H5d find, where you basically provide a source and the destination type, and you are basically asking the library, hey, do you have a conversion for these types? And this H5d find returns, this is basically a pointer, this is a callback function. H5t underscore conft is basically a callback function. So this would return a pointer to a function that can do that conversion, or as the documentation says, it will return null if there is no such conversion. And I tried it, so even in the case when it works, so when you read UTF-8 to UTF-8 and then ASCII to UTF-8, and I run this, I get in both cases null back here. So there is no type conversion routine being installed. So it's a little bit of a mystery why, again, why it works in one case and not the other.
Well, thank you so much for considering it, and we are glad that we can help somehow. So please let us know if there's any.
No, thank you. I mean, this is exactly, those are the kinds of contributions that we are looking for. Thank you. Are there any other questions? Because again, I have other things to go over, but this is about your questions, and if there are other questions, let's hear them. I can quickly check that Google document. Someone else left maybe a question. In the meantime, no, that's it for now. So are there other questions for the moment? No? Okay. Then I'll quickly go over a few last week's highlights. One thing that I found interesting is someone, as we have seen for Python, for Node.js and so forth, people are going back to the file format specification and really are trying to implement standalone, independent of the HDF5C library, readers, and in some cases writers. And there is a gentleman who maintains this project called HDF5.net, and he just did an alpha release, the 4th alpha release of a pure .NET, meaning there is no dependence on the HDF5C library. And it's out there and available. There's a Nugget package, so very easy to install. And so that's very interesting. That caught my eye. And then as a reminder, we still have our call out there for papers and presentations for our 2021 HUG meeting. And the deadline for abstracts is June 1st, so we still have a little bit of time. And then the event itself is spread over 3 days in October. And then on the forum, I just spoke with Laurie earlier, the BOF, because of which we canceled last week's clinic. There might be a recording available. We are trying to find out if it's available and where it is, and we will post that on the forum, because yeah, these BOF, these birds of a feather session are always interesting, because yeah, people talk about, I think there was a discussion about asynchronous IO and event sets and so forth, and so things of interest, and if there's a recording, we'll highlight that. Now on the forum, right, there was an interesting question someone asked about accessing attributes, and there was a little bit of confusion maybe, and about how you can refer to an attribute of an object in an HDF5 file. And so just a quick recap maybe. In HDF5, if you wish, there are several different things that you can identify or refer to through path names or strings or something like that. For example, file level path names in external links, for example, the attributes themselves, and then of course most prominently the path names to objects that look like path names in a file system, or for example the field names in a compound type. Now these are, if you wish, all different namespaces, and unfortunately you cannot mingle them, because in some cases they are also subject to different rules, as very topical. Some of them, for example, can only be ASCII encoded, and some of them you have the full Unicode character set or code point set available to you. So for example, for these path names, you have the full Unicode set available to you, with the exception of the slash character, which is reserved as a separator, but everything else is fair game. Likewise for attribute names, they can be arbitrary Unicode strings. However, for example, the field names of compound types, they have to be ASCII. For example, the tags of opaque types, they have to be ASCII, and actually are limited, I believe, to 255 characters. And so, because in that post somebody was asking about, or somebody was thinking that if I want to refer to an attribute of an object, I can just provide the path name to this object, and then basically concatenate or attach, append the name of the attribute to that. But that, of course, even if you could, that creates all kinds of problems, because it creates ambiguity in the sense of, given such a path, how do you resolve that ambiguity? I mean, given enough time, this would be a very slow call. You could just try all kinds of possibilities, to decide, well, this is a path to an object or this is a path to an attribute. But what do you do, for example, if both are valid, in the sense there is an object that has an attribute of that name corresponding to that last segment, but there's also an object where that linked name is also in use. So it would create interesting ambiguities, but we can't have that, and that's why these different namespaces, so to speak, are disjoint. Then there was this discussion. Somebody was asking about the HDF.NET library that's sort of unfortunately deprecated, very old. But there is a newer Nugget package available based on HDFP invoke for 1.10 on Windows, but then also since the newer versions of the .NET framework are available across many other platforms, Linux, Mac OS, and so forth. There is also a variant that supports this .NET Core or .NET Standard, as it's called now. But we are also looking at the moment, there is a small group of interested parties in .NET, well, at least in terms of participation. There might be a tremendous user community out there, but there are relatively few people that really participate actively in the development. But for example, Swig, this is that's been around for a very long time, and it has come a long way. It might be a good path forward to actually base future versions of a .NET wrapper that basically wraps the C API on Swig with the benefits for automation and parsing and so forth, so we can really then automate more things and really focus on platform differences, how the library finds the shared library or the DLLs on the respective platforms and so forth, and just make that as robust as possible. Finally, then, there was an ongoing thread about having a one-dimensional sort of data set distributed across multiple processes. And somebody was asking for an example where what happens if you have different numbers of elements in an array across these processes, including maybe the case that some processes don't have any array elements, and then writing in parallel to a chunked data set, and then are there any constraints on the size of the chunked data set? So if you follow up on this thread, I wrote a little example that I thought was more interesting. Unfortunately, in this case, someone picked up an example that we had posted years and years ago, and which for my taste was more harmful than informative. And so hopefully that helps. And there was also a question about interaction with Darshan, and the person had trouble running Darshan, profiling that application with Darshan. But to me, it was more likely that there was a programming error somewhere rather than Darshan misbehaving. Okay, then we have a few more tips and tricks, and maybe coming soon. But before I do that, just a question, since we have about 5 minutes left. Are there any other questions so far? No? Okay, good. Then I will quickly talk about what we are thinking about coming soon. And partially, as a result of that buff, Quincy suggested that now with asynchronous I/O and so forth, the question of what happens to open HDF5 handles or IDs, these things, these HID_T things, what happens to them when your program ends? So that was maybe a question in the past that wasn't so critical because in the end, well, first of all, there was a default set for files or for virtual files, and and there are some routines where you can actually discover what handles, what open handles are there, attributes handles, so filtered by object type, if you wish. But then this sort of takes on a whole new life now with asynchronous I/O, where you basically have these event sets where you can bundle together multiple I/O operations. And let's say an error occurs or the program shuts down, what really happens to these handles, and what are the implications for your data, for transactions that might be in progress that have not completed for whatever reasons, and how to deal with that. And we will definitely take that in pieces because it's a large topic, and we will definitely start with sort of the current behavior, the pre-asynchronous I/O behavior, but then we will also sort of talk about now that we have the ability to do asynchronous I/O, how that picture changes, and what new knobs and dials there are for you to take control to make sure that your application shuts down cleanly and you don't lose data and so forth. In the tips and tricks section, again, just going back to the HDF5.net, where this person went out and went back to the HDF5 file format specification. There is a little bit of a, I would say, a mystique out there, undeservedly, that the HDF5 file format is sort of this excruciating, complicated thing, and most of the library code has to do with the byte manipulations of this format and so forth. And that's really a myth. That's not the case, because there is really, if you do a line count on the code that deals with the formatting of the HDF5 file format, that's a tiny fraction of the overall library code. So most library code has nothing to do with the file format and so forth. But I think what also helps is to see this a little bit in perspective. So again, unfortunately, maybe we haven't done such a stellar job in presenting this material. So if you go to our portal, this is the file format specification, the current, so to speak, the current release of the file format specification. And that's a pretty long thing. That's, if you want to print it to PDF, that's, I think, 200 pages, if not more, or something like that. But that misses in a way that that's not how it started, or this is the result of an evolutionary process that from rather humble beginnings. So what we did is, for example, collect these different generations of file formats. So if you go here to our experimental, we are in the process of converting large parts of the documentation of the reference manual in particular to Doxygen. Here we've lined up the earlier versions of the file format specification, starting with version 1.0, 1.1, 2.0. So, and here, if you look at the first version, 1.0, it's actually rather short. And it definitely, if you print it out, it's much less than 100 pages. It's probably 20 or 30 pages or something like that. But if you start from here, all the core ideas about the different levels, how objects, what we call objects, the data sets, the data types, and so forth, how they are represented, how they are encoded, all these ideas are already there in format specification version 1. And if you start from that and then work your way up through versions 1.1, 2.0, up to, it's really, the changes are, I wouldn't say not exactly minuscule, but they are really sort of, yeah, making optimizations, making accommodations for new features that were added to the library to support them. But the core principles and the core ideas, they are there in version 1.0. And so I just thought it's worthwhile pointing that out. If you have always wanted, and you said, I wish I could live without the dependence of the C library, that's okay. After all, the C library is just one implementation, call it the reference implementation, or a reference implementation. But you've always, the moment you looked at the file format specification, you said, "Oh my, I'm never going to get around that." I would encourage you and go back to version 1, look at it, just think it over for a while. It's not really that complicated, and then you might be sort of encouraged to go back to your task and maybe start simple, start with that specification, and then start building up features from there. But it's important to understand, yeah, it's not that complicated as people sometimes make it out to be. Okay, unfortunately, time is up. Thanks for coming. Thanks for our great contributions, and we'll be here next week to answer your questions and cover some of these topics maybe. Thank you. Bye.
Thank you.
Thanks.